The upper leg length of a 20 to 29-year-old males is normally distributed with a mean length of 43.7 centimeters and a standard deviation of 4.2 centimeters. What is the probability that a randomly selected 20 to 29-year-old male has an upper leg length that is less than 40 centimeters? So for the first problem, we are simply trying to figure out this leg length compared to the population, right? There's no sample size, so we don't have to alter our information. So we just are using the normal CDF. We're not changing any information whatsoever. So we have our average, 43.7. We have our 40 centimeters. And we need to be less than 40 centimeters, which is everything to the left. So we go to our calculator, and we're going to continue the process of vars, second, all that good stuff. Our lower bound number, we're doing everything from the left, so that's going to be -1 E99. Our upper bound number, where we're going to stop at, is 40 centimeters, so we're going to put 40. Our average is 43.7. And then our standard deviation is 4.2. We hit enter. Oh, go to. I'll put a subtraction sign instead of a negative. It happens. We get the probability of 0.189. So then the answer for A. 0.189. B. A random sample of 9 males who are 20 to 29 years old is obtained. What is the probability that the mean upper leg length is less than 40 centimeters? So now we have a sample size. So as soon as we get a sample size, we have to alter our information. So we need to change from mu and sigma to mu x bar and sigma x bar. So mu x bar is the same thing as mu, so that doesn't change. But sigma x bar is different. So sigma x bar is the old sigma, 4.2, our population sigma, divided by the square root of our sample size, divided by 9. So that's 4.2 divided by 3 gives you 1.4. So then that's the information we're going to use now to find the normal distribution. So we'll go to the calculator. Second vars, normal CDF. Lower bound still -1 E99. Upper bound 40 centimeters. Average 43.7. But our standard deviation now is 1.4 because we have a sample size. So we have to shrink it down. We have to scale it to our sample size. And then we hit enter. There's our probability, 0.004. What is the probability that a random sample of 12 males who are 20 to 29 years old results in a mean upper leg length that is less than 40 centimeters? Again, they've given us a sample size, so we have to shift our information to match with our sample size. So for C, mu x bar, still the same mu, so that's 43.7. Our sigma x bar, though, will now be 4.2 divided by the square root of 12, which is going to give us some sort of weird decimal. So let me use that real quick. .212. 1.212 is our sigma, our standard deviation. So then we go to the calculator, figure out the probability. Distributions, normal CDF, -1 E99, upper bound 40 centimeters, average 43.7, standard deviation 1.212. And our probability for this question is 0.001. So then the answer for C is 0.001. What effect does increasing the sample size have on the probability? So let's look at it. Well, 0.1. We had 9, we had 0.004. We had 12, we had 0.001. So increasing the sample size, we actually decreased the probability. Decreased. And then E, we won't worry about it.